A team provisioned multi-AZ for their database and assumed read traffic would spread across both nodes. It didn't. The standby was never readable, and the bottleneck they designed around was still there. The fix was one architectural swap, and the clue was a single word in the original requirement they'd skimmed past. That's the setup. This is Cloud Architect Path from Stack Lessons. By the end of this video, you'll have practiced one discipline. Read the actual requirement first. Eliminate what's architecturally impossible, then decide on the single constraint that matters. That's how engineers avoid rework in production, and it's exactly how the exam tests whether you can do it under pressure. The 3 checkpoint episodes each drilled one domain at a time: security, then resilience, then performance. The production patterns episode showed you these same decision forks living inside real architectures. Now we mix all 4 domains together in random order, exactly the way the real exam throws them at you. Here's the format: 18 original scenarios weighted to the blueprint, 5 on security, 5 on resilience, 4 on performance, and 4 on cost. For every single one, we run the same protocol. First, read the last sentence, the actual qualifier, before you read the scenario body. Then eliminate any option that violates a hard capability. Finally, choose the survivor on the one dominant constraint. When I prompt you to pause, stop the video, commit to an answer, and then watch the elimination unfold. Security failures cascade harder than performance issues. A single credential leak can blow open an entire account, and the blast radius is far wider than a slow query. That's why security decisions carry the highest stakes in real architectures, and why we drill security scenarios first. The exam reflects that same priority. Security is 30% of scored content. Resilience is 26, high performing is 24, and cost optimized is 20. Our 18 scenarios split roughly 5, 5, 4, and 4 to match. This is the whole discipline in one line. Read the qualifier first. Eliminate the impossible, then choose on the dominant constraint. In production, the critical requirement is often buried in a single line of the spec, and missing it means rework, outages, or an architecture that technically functions but fails the actual need. Building the habit of finding that constraint before evaluating options is how experienced engineers avoid that failure mode. We start with security, the heaviest domain. 5 scenarios ahead, and each one lands on a service boundary the exam leans on constantly. IAM roles, KMS versus CloudHSM, security groups versus network ACLs, S3 encryption enforcement, and picking the right detective service. Question 1. An application running on EC2 needs to write objects to an S3 bucket in the same account. The options are: store access keys in the app config, create an IAM user for the instance, use a bucket policy on its own, or attach an IAM role through the instance profile. Read the qualifier first. Which approach is most secure? That word, secure, is your filter for everything that follows. Pause here and commit. Which one of these gives you temporary, automatically rotating credentials with nothing sitting on disk to leak? Now, eliminate. Stored access keys are long-term secrets written to disk. They leak in snapshots, in machine images, in anyone's console. That's the key under the doormat, so it's out. An IAM user for the instance is better, but it's still long-term credentials you have to manage and rotate yourself, so it's out. A bucket policy on its own handles the resource side, but the instance still has no identity to present, so that's out too. The correct answer is the IAM role attached through the instance profile. Think of it as a hotel keycard. It works for your stay, expires automatically, and can be revoked remotely. Temporary TS credentials, no stored secrets. Whenever compute needs another service, this is the answer. Question 2. A financial institution must encrypt data on dedicated single-tenant hardware, and their auditors demand proof of physical key isolation and full key custody. The options are KMS with a customer-managed key, KMS with an Amazon Web Services-owned key, CloudHSM, or S3 managed encryption. The qualifier is the phrase dedicated hardware and sole custody. Hold that phrase in your head. Here's the split. Both KMS options run on shared multi-tenant hardware. KMS is fantastic. It integrates natively across nearly every service and logs everything to CloudTrail, but it fails this specific test because the hardware isn't single-tenant. So both KMS answers are out, and S3 managed encryption is out for the same reason. CloudHSM is the correct answer. It gives you dedicated single-tenant modules, you hold sole custody, and the keys are exportable. The trigger words are always dedicated hardware and full key ownership. When you see those, reach for CloudHSM. Now watch how one word flips the whole answer. If the qualifier had said easy integration with S3 and RDS, or managed with a CloudTrail audit trail, CloudHSM would suddenly be the wrong answer and KMS would win. Same services, opposite choice. The qualifier is doing all the work. Question 3. A company must explicitly block all traffic from a single known bad IP range from reaching every instance in a subnet. The options are a security group deny rule, a security group allow list, a network ACL deny rule, or a root table black hole. The qualifier is the word explicitly deny. That one word rules out most of the list before you even think hard. Pause and decide. Only one control inside of VPC can express an explicit deny rule. Which one is it? Eliminate. A security group deny rule simply cannot exist. Security groups are allow only, full stop, so it's out. A security group allow list would force you to rewrite every legitimate source, and it still can't single out one bad address, so that's out. A root table black hole routes by destination, not by a malicious source, so it's the wrong tool entirely. The correct answer is a network ACL deny rule at the subnet edge. The network ACL is stateless and supports both allow and deny rules, which makes it the only place you can explicitly block that IP. One catch that bites people in production and on the exam. Because a network ACL is stateless, it has no memory of a flow. Return traffic needs its own explicit rule allowing the ephemeral port range 1024 through 605535. Forget that, and your replies vanish silently. Question 4. Compliance requires that every object in a regulated bucket is encrypted with one specific customer-managed KMS key. The options are enable default SSEKMS, turn on versioning, add a bucket policy that denies non-compliant uploads, or enable block public access. The qualifier is the word enforces, not applies, not enables, enforces. Eliminate defaults SEKMS is only a fallback. It's applied when the caller emits an encryption header, but it will happily accept an upload encrypted with the wrong key. It doesn't reject anything, so it fails enforcement and it's out. Versioning keeps object history and is irrelevant here, so it's out. Block public access guards who can reach the bucket, not how objects are encrypted at upload, so it's out. The correct answer is a bucket policy with a deny on put object, conditioned on string not equals against the SSEKMS header and a specific key ID. That's the sign on the door and the bouncer enforcing it. This is exactly how Megacorp locked down its contracts bucket back in episode 7. The S3 documentation is worth quoting directly here. It says all Amazon S3 buckets have encryption configured by default, And every new object is automatically encrypted at rest, with S3 managed encryption as the default. Read that carefully. Encryption is already on. That's why the question isn't about enabling encryption, it's about enforcing a specific key, and only a bucket policy can reject the ones that don't comply. Question 5. A security team gets an alert that an IAM credential may be compromised. They need to analyze historical API calls and network connections to work out the scope and the root cause. The options are guard duty, inspector, Macy, or Amazon detective. The qualifier is investigate the root cause of an existing finding. That verb, investigate, is different from detect, and it matters. Eliminate. Guard duty is what raised the finding in the first place. It detects suspicious behavior, but it doesn't dig back through history to explain it. So, it's out. Inspector scans compute for known vulnerabilities, which has nothing to do with credential misuse, so it's out. Macy discovers sensitive data in S3, a completely different problem, so it's out. The correct answer is Amazon detective, which builds a graph of behavior over time and lets you investigate the root cause of an existing finding. The mental model is simple. Guard duty says something is wrong. Detective explains why. Keep this map in your head. Suspicious behavior or an active threat points to guard duty. Vulnerabilities in your compute point to inspector. Personal data sitting in S3 points to Macy. A single normalized dashboard across all of them is security hub. And why did it happen? The root cause dig is Amazon detective. The trick is to match the verb in the question, detect, scan, discover, aggregate, or investigate, straight to the service. Security domain in 4 rules. When compute needs another service, it's always an IAM role, never stored keys. When the requirement is dedicated hardware and sole custody, it's CloudHSM, and for everything else, it's KMS. An explicit deny of an IP lives only in a network ACL. And to enforce a specific encryption key, use a deny unencrypted puts bucket policy. On to resilience. 5 scenarios about staying available and recovering fast. We'll hit multi-AZ versus read replicas, choosing the right load balancer, matching a disaster recovery strategy to its numbers, Route 53 routing, and decoupling with queues. Question 6. A production MySQL RDS instance is hitting high CPU because a daily reporting job runs heavy select queries against the primary. The options are convert to multi-AZ, add a read replica, scale the instance up, or enable a multi-AZ DB cluster. The qualifier is resolve the read pressure with minimal application refactoring. Pause and decide. One of these options is the most common mistake teams make when they need to offload reads. It feels like the right call, but it doesn't solve the actual problem. Which one is it? Eliminate. Multi-AZ is the classic wrong answer here. The standby exists only for failover and is not readable, so it does nothing for your reporting load. Out. Scaling the instance up buys headroom, but the reporting queries still compete with real-time traffic on the same primary, so it doesn't fix the real problem. The multi-AZ DB cluster does give you readable standbys, but it's heavier than you need for pure read offload, so it's not the best fit. The correct answer is a read replica. Point the reporting job at an asynchronous read-only copy, and the primary is freed. Reduce read load, choose a replica. Survive an AZ failure, choose multi-AZ. 2 different dials. Question 7. A business-to-business SaaS app serves traffic over HTTPS, and corporate clients must whitelist a single fixed IP in their firewalls. The options are an application load balancer with a fixed hostname, a network load balancer with an elastic IP, an application load balancer behind Global Accelerator, or a gateway load balancer. The qualifier is which load balancer provides a static IP for whitelisting. Eliminate. The application load balancer has no elastic IP. Its addresses change as it scales, which is exactly the outage Megacorp hit back in episode 16, so it's out. A fixed host name doesn't help when the client's firewall needs a fixed number. The gateway load balancer routes to inline security appliances, not a public app front door, so it's out. The correct answer here is the network load balancer with an elastic IP, the only load balancer type that gives you a static, whitelistable address. Now the nuance. If the question had also required a web application firewall, the answer would shift to global accelerator in front of an application load balancer with a firewall attached. Because the network load balancer can't do layer 7 inspection. Question 8. A healthcare app needs a recovery point objective of 30 seconds and recovery time objective of 10 minutes for a full regional failure. Cost matters, but availability takes priority. The options are backup and restore, pilot light, warm standby, or multi-site active-active. The qualifier is the strategy that best fits that exact pair of numbers. Pause and decide. Seconds of data loss. Minutes to recover. Which disaster recovery tier lands exactly on those two numbers? Eliminate. Backup and restore recovers in hours. Far too slow for a 10-minute target, so it's out. Pilot Light replicates your data continuously, but keeps compute switched off. So recovery takes hours while you provision and start those servers, and misses 10 minutes, so it's out. Multi-site active-active would meet the target easily, but it's the most expensive option, and the ask was availability, not zero downtime, so it overcorrects and it's out. The correct answer is warm standby, a scaled down but production environment that gives you seconds of RPO and minutes of RTO. It's the generator already spinning, ready to take load. The Amazon Web Services Disaster Recovery White Paper draws the line precisely. It says Pilot Light cannot process requests without additional action taken first, whereas Warm Standby can handle traffic at reduced capacity immediately. Pilot Light means turn on servers and then scale up. Warm Standby means only scale up because everything is already running. That single word, running, is what separates the two. And it's what the exam tests. Question 9. Servers run in two regions, US East 1 and EP Southeast 1, and users should reach the endpoint with the best network performance, not necessarily the nearest one. The options are simple: geolocation, latency-based, or failover routing. The qualifier is route by measured network performance. Eliminate. Simple routing just returns records with no multi-region logic at all, so it's out. Geolocation routes by the user's country or continent. Nearest is not the same as fastest, and that's the distinction that matters here, so geolocation is out. Failover is active-passive disaster recovery, not performance routing, so it's out. The correct answer is latency-based routing, which sends each user to the region with the lowest measured network latency. A user in London might actually route to Virginia if that path is faster for their internet service provider. That's the whole point. Question 10. An order event must be consumed independently by 3 services: inventory, shipping, and notification, and each one needs its own retry logic and its own dead letter queue. The options are a single SQ, SNS on its own, SNS fanning out to 3 SQs, or event bridge to 1 queue. The qualifier is independent delivery with per-service buffering and failure isolation. Eliminate. A single less QSQ lets only one consumer see each message, so 3 services can't all react to the same order. Out. SNS on its own broadcasts the message, but it gives no per-subscriber buffer and no retry, so a service that's down just misses the event. Out. Event bridge into 1 queue still collapses down to a single consumer buffer, so it's out. The correct answer is an SNS topic fanning out to 3 separate SQSQs. Picture SNS as a newsroom printer stamping out the story, and each queue as a journalist's own inbox. Every service gets its own copy, its own buffer, and its own dead letter queue. If one is down, its inbox piles up safely while the others keep working. Here's the pattern on a slide. The order event lands on a single SNS topic. From there, it fans out to 3 independent SAA-C queues, one for inventory, one for shipping, one for notification. The value is in that separation. Each queue is its own buffer with its own retry and its own dead letter queue, so a failure in one downstream service never touches the other two. This is Amazon's own canonical decoupling design. Resilience and 4 rules. Read offload is always a read replica, because the multi-AZ standby is never readable. A static IP means a network load balancer, and add a firewall to that, and it becomes global accelerator with an application load balancer. Match the RTO and RPO pair to the exact disaster recovery tier. Don't overshoot into needless cost or undershoot on speed. And multiple independent consumers means SNS fanning out to SQS. Domain 3 is performance. 4 scenarios on latency, throughput, and serverless analytics. We'll work through DAX versus ElastiCache, choosing GP3 storage, querying with Athena, and Kinesis data streams versus Firehose. Question 11. A mobile game uses DynamoDB and sees read latency spikes at peak hours. The team wants to bring reads down to microseconds with minimal code change. The options are ElastiCache with Redis, DAX, add a read replica, or increase provision read capacity. The qualifier is 2 things at once: microsecond reads and minimal application code change. Eliminate. ElastiCache with Redis genuinely caches, but you have to write real application code to manage cache reads and writes, which fails the minimal change half of the qualifier. Out. A read replica is RDS vocabulary. DynamoDB doesn't work that way, so it's the wrong service entirely. Out. Adding read capacity units raises throughput, but it doesn't lower the latency floor to microseconds. Out. The correct answer is DAX, the DynamoDB accelerator. It's a drop-in cache built specifically for DynamoDB, a pre-installed turbocharger for that one engine, delivering microsecond reads with almost no code change. One catch to remember: DAX only accelerates eventually consistent reads. If the application demands a strongly consistent read, that request bypasses the cache and goes straight to DynamoDB at normal latency. So if a question stresses strong consistency, DAX stops being the easy win. Question 12. The 500 gigabyte GP2 volume needs 6,000 input-output operations per second without growing the volume, and cheaper than GP2. The options are grow the GP2 volume to 2 terabytes, switch to GP3, move to IO2 block express, or switch to ST1. The qualifier stacks 3 constraints: more IOPS, no size increase, and lower cost. Here's the elimination. Growing GP2 to 2 terabytes works, but GP2 ties IOPS to size, so you'd be paying for storage you don't need just to buy performance. Wasteful, and it violates no size increase. IO2 block express is overkill and more expensive here. ST1 is a hard drive. Can't even be a boot volume. Wrong profile entirely. The correct answer is GP3. With GP2, the pipe's flow rate is fixed to its diameter. With GP3, you dial the diameter and the pressure independently. A baseline of 3,000 IOPS at any size, configurable up to 16,000, and about 20% cheaper per gigabyte. You just dial up to 6,000 IOPS on the same 500 gigabytes. Question 13. A data team must run ad hoc SQL against 10 terabytes of JSON access logs already sitting in S3, serverless, with no provisioning. The options are load into Redshift, spin up EMR, use Amazon Athena, or use S3 Select. The qualifier is serverless SQL with no infrastructure to manage. Eliminate. Redshift needs a provisioned cluster and a step to load the data first, which fails both serverless and no management, so it's out. EMR means you size and manage a Hadoop cluster, so it's out. S3 Select pulls fields from a single object. It can't run a query across 10 terabytes of many files, so it's out. The correct answer is Athena, serverless SQL straight against S3, no cluster, build only for the data each query scans. The data's already there, so you just point SQL at it. Question 14. A platform must process clickstream events sub-seconds, and it must be able to reprocess the last 24 hours if a consumer bug is found. The options are Kinesis Data Streams, Amazon Data Firehose, SQS Standard, or SNS. The qualifier is two capabilities together, real-time and replay. Eliminate. Firehose keeps no history and imposes a minimum 60-second buffer for S3 in most destinations, so it fails both the real-time and replay requirements in one shot. Out. SQS Standard deletes a message once it's processed, so there's no way to rewind. Out. SNS is fire and forget push, with nothing to replay. Out. The correct answer is Kinesis Data Streams. It ingests sub-second, retains records for up to 365 days, and lets consumers rewind and reprocess. That live conveyor belt you can rewind is exactly what the qualifier asks for. Performance in 4 rules. DynamoDB plus microseconds plus minimal code is DAX. Complex data structures or many data sources is ElastiCache. GP3 is the general purpose default, with IOPS decoupled from size. Data already in S3 plus serverless SQL is Athena. And replay or sub-second means data streams, while managed delivery straight into a sink means Firehose. Last domain, cost. These 4 scenarios are sneaky because the tempting answers are often technically correct but miss a hidden cost. We'll cover spot versus reserved, picking an S3 class, gateway endpoint versus NAT, and the right tool for right sizing. Question 15. A nightly genome sequencing job runs 4 to 6 hours, checkpoints its progress every 30 minutes, and resumes cleanly from the last checkpoint if it's interrupted. The options are on-demand, 1-year standard reserved, spot instances, or dedicated hosts. The qualifier is minimize cost for interruption-tolerant work. Eliminate. On-demand offers no discount, and there's no reason to pay full price for work that already tolerates interruption. Out. Reserved is a commitment sized for steady, around-the-clock usage. Paying that for a job running a few hours a night is wasteful. Out. Dedicated hosts exist for licensing isolation, not cost minimization. Out. The correct answer is spot instances, up to 90% off. The 2-minute interruption notice is a non-issue here because the job checkpoints every 30 minutes and resumes cleanly. That's the exact profile Netflix uses Spot for on its video encoding. Whenever you see interruptible and checkpointed, think Spot. Question 16. Raw video must be kept for 7 years, accessed only during legal disputes about once every 2 years, and a 12-hour retrieval time is perfectly acceptable. The options are S3 Standard, Standard Infrequent Access, Glacier Instant Retrieval, or Glacier Deep Archive. The qualifier is most cost-effective given that 12-hour retrieval tolerance. Eliminate. S3 standard is full price for data touched once every 2 years. Wildly overpriced. Out. Standard infrequent access is still warmer and pricier than data this cold needs, so it's out. Glacier instant retrieval pays a premium for millisecond access, and the scenario says 12 hours is fine, so you're paying for speed you don't need. Out. The correct answer is Glacier Deep Archive, the lowest cost tier by far. Its retrieval window is 12 to 48 hours, which comfortably fits the 12-hour tolerance. That's offsite tape in a vault 3 states away, cheap as possible, and you're happy to wait. Always check the minimum storage duration before you commit to a cold tier. Deep Archive carries a 180-day minimum, so deleting early still bills you for the full period. For 7-year retention, that's a complete non-issue, but on a shorter-lived object, that penalty is exactly the hidden cost the exam likes to hide. Question 17. Private subnet instances upload 5 terabytes a month to S3, and that traffic is driving up NAT gateway data processing charges. The options are add a second NAT gateway, move the instances to public subnets, add a VPC gateway endpoint for S3, or buy a NAT reserve plan. The qualifier is reduced cost with no application code change. Eliminate. A second NAT gateway adds cost rather than removing it. Out. Moving instances to public subnets is a security regression, exposing servers that are meant to stay private. Out. And NAT has no reserved pricing, so that option doesn't even exist. Out. The correct answer is a gateway endpoint for S3. It's free, it routes S3 traffic directly over the Amazon Web Services backbone, and it needs 0 code change. The NAT gateway is a toll booth charging for every gigabyte. The gateway endpoint is a free on-ramp straight to the S3 campus. This is exactly the fix Megacorp used back in episode 10. The VPC documentation says it in 2 plain sentences. There is no additional charge for using gateway endpoints. And Gateway VPC endpoints provide reliable connectivity to Amazon S3 and DynamoDB without requiring an internet gateway or a NAT device. Free, and it removes the NAT device from the path. That's why engineers call this the easiest money they ever saved on Amazon Web Services. Question 18. Our last one. A company wants to identify EC2 instances running under 20% CPU and memory so they can downsize them, and they want this driven by actual utilization data. The options are Cost Explorer, Trusted Advisor, Amazon Web Services Compute Optimizer, or CloudWatch Alarms alone. The qualifier is utilization-based right-sizing recommendations. Eliminate. Cost Explorer shows you what you're spending, but it doesn't map utilization to a specific instance recommendation. Out. Trusted Advisor runs broad account checks across many pillars, and its full checks require business or enterprise support, so it's not the precise free tool here. Out. CloudWatch Alarms raise a signal when a threshold trips, but they never recommend a target size. Out. The correct answer is Compute Optimizer. It reads CloudWatch utilization metrics and recommends right-size configurations for EC2, EBS, Lambda, and auto-scaling groups, and it's free to enable. This is the tool that flagged Megacorp's over-provisioned fleet back in the cost episodes. Cost in 4 rules. Interruptible and checkpointed means spot. Steady around-the-clock usage means reserved instances or savings plans. Match the retrieval requirement to the coldest tier that still meets it, and always check the minimum storage duration. For S3 or DynamoDB traffic from private subnets, a free gateway endpoint beats a NAT gateway. And utilization-based right-sizing is Compute Optimizer, not Trusted Advisor. Before we wrap, let's review the architectural decisions that separate reliable systems from fragile ones. Teams that reach for multi-AZ standby to offload reads end up with the same bottleneck they started with. The standby isn't readable, so the right answer is a read replica. Teams that pick an application load balancer for a static IP requirement discover it has no elastic IP. A network load balancer is what actually holds a fixed address. Security groups are allowed only by design, so blocking a single IP requires a network ACL deny. Firehose buffers for up to 60 seconds and has no replay capability. When you need true real-time processing or the ability to reprocess, data streams is the right architecture. And standard and frequent access is too warm for data that's touched once every 2 years. When the retrieval tolerance is that wide, deep archive is the correct tier. Carry one habit into exam day. Read the last sentence qualifier before you read the scenario body. Eliminate every option that violates a hard capability first. That shrinks 4 choices to 2 almost instantly. Then decide the survivors on the single dominant constraint. When 2 options both work, prefer the simplest managed service that meets the requirement and reject anything that adds cost or complexity the scenario never asked for. And above all, remember that knowing why a wrong answer is wrong will carry you further than memorizing any right one. Go earn that pass. Okay, that's a full wrap on practice exam walkthrough. 18 scenario questions. If this is making your prep smoother, subscribing keeps it free and reaches more students like you. Drop a comment on what surprised you most. Want a specific certification covered next? Name it below. And tell me how the pacing and visuals work for you. I tune to that. Catch you in the next